All right, last lesson of the year. In my last class in geometry, we just did the last lesson of the year as well, so that's fun. All right, we're talking about this thing called radians and the unit circle. I mentioned a couple times a unit circle, didn't I? What did I say the word unit represented here? It means one, right? And it's a circle, and what is the one on that circle? The what? The radius. The radius. The radius of the circle is 1. We'll get to that in a little bit. That's towards the end. The radians is the first part. Do you remember when I used a graphing calculator on here? I always had to change it from degrees to radians, okay? This is what radians is, okay? This is why I didn't want it in radians then, because I was using degrees, all right? But there are another, it's not technically a unit. It's not like in feet, inches, that kind of thing. Radians is a little bit different. It's not really a unit. And some people, sometimes it acts like it is, but it's really not. All right, I'll talk about it in a second. Let's do a definition of radian. Okay, so we're going to talk about a radian. It says the radian measure. No, I'm not going to write the whole words out because it's got a little formula. I'll just do it here. But let me read it though. It says the radian measure of an angle. Okay, and that angle, I will say this, we're going to use theta, right, for that unknown angle. So when you measure an angle in radians, what is it? It's the ratio. What does that mean to be a ratio? Divide, a fraction. It's a comparison between something and something else. Okay, we usually write it as a fraction. It's the ratio of its intercepted arcs, or its arc length, the length of the arc. All right, so the length of the arc is represented by the letter S. I'm not really sure why. I'm sure there's a reason, but the length of the arc, we know what arcs are, right? We did that in geometry last year. We talked about arcs, and I'll show it to you in a second. All right, but the length of an arc is S. So what is the radian measure? It's the ratio of its intercepted arc, its arc's length, to the radius of the circle. Okay, obviously radius, what letter do we use for radius? R. It's R. So what is the angle? Theta. It's equal to the ratio of the length of the arc, which is S, over the radius. So when I compare those two together, that is what it means to be a radian. I'll put it right there. All right, and we're going to use a little different version of that a little bit later. All right, so the S, again, it's all here. Wrote it all out. The S is the length of the arc, R is the radius, and so that's what it is, but it's going to be that in radians. Let's talk about what a radian is. And I got a video, don't forget to remind me to show you a video. It's a quick 5-minute lesson, I think, or 5-minute video. I'll show you. And they got cool graphics and all that kind of thing. My graphics are okay, but not as cool as what this video is. So figured I would do that. All right, enough of that. Let's do this. So this is not technically a unit circle just yet. We're going to get to it. And let's do a circle. Just a big old circle about right there. We'll center it at the origin of this X and Y axis. All right. So let me just kind of explain to you so you can kind of see visually what a radian is. Now, let me see. I think I did a problem. I should know what the angle measure is off the top of my head. 1 radian, 57.3 degrees. So how they created the wheel, I don't think so. So watch, if I went to about right there, okay, I don't know where it is exactly, but that's pretty close to 1 radian. So let's put that in a different color. If I would have been prepared, I think about this like when I'm actually doing the video, and I should have thought of this before. When I was taking my notes, I thought about it, and I thought, I'm not going to be able to do this. But I have done this before, where I've taken a circle like a cardboard, right, and get a nice perfect circle, and then you can find the center, and you've got the radius. So just picture for a moment, by the way, we could do it. This would also be a radius from there to there, wouldn't it? Okay. So I got 2 radii. Let's say I picked up that radius right there, and it was bendy, all right? It's not completely straight. But if I took that radius, or the length of the radius, and I started here, and I took that length, and I bent it around the circle. You follow me? So picture it, I took a piece of string, right? I went from one radius, from the center to the outside of the circle, and then I took that string, and I took it right here, took that red string right there, and I wrapped it. It would probably go to around there, okay? It's not exactly, but it's pretty close. Everybody see that? So that, let's do that in a different color. What color do you want to use? Blue, okay. So I'm going to do it a little bit thicker. So if I took that radius and stretched it along the circle from here to here, right? Well, if I just stretched it out, then I connected it from there to there. I should say that, okay? That right there, the length, right, which is, what letter are we using? S. Okay, the length of this blue one is the same as the length of this radius. Everybody got that? The angle that it forms is considered to be 1 radian. It's an angle, right? We know how to measure angles in degrees, but now we're going to measure them in radians. And what is 1 radian? 1 radian is the angle that's formed by taking a radius and stretching it around the circle, okay? So that angle right there, if that's the distance, if that's the length of that radius, then that's considered to be 1 radian. Now, if you did it to a bigger circle, the radius would be bigger and the distance around the circle would be bigger, wouldn't it? The length of it would be longer. But the angle that it forms would be the same. So I could take a little tiny circle, take the radius, stretch it around. I could take a big old gigantic circle, take the radius and stretch it around. It's still going to give me the same exact angle, all right? You with me on that? All right, so that's considered 1 radian. Now, watch this. This is kind of cool, I think. Now, I might not be able to do this exactly, but it'll be pretty close. So let's say I do another radian, all right? So I take another radius and I start here and I go, I don't know, let's do it in a different color this time. Let's go green. I'll do yellow last. All right, so what if, again, I want to try to go the same amount. This is not going to be perfect, all right? It's just going to be, so tell me when you think this green one is the same length as the blue one. Oh, that's a little squiggly, isn't it? Is that a little too short? Maybe about right there? That's pretty close. Again, we're just trying to be close. And so now, watch this. So this is 1 radian. This is another radian, that green one. So what do we got so far from here to here? What is this angle from there to there? That's 2 radians. Everybody see that? Let's do it again. So I'm going to start here, and I'm going to go, but it's going to fall just a little short. All right, so pretend these are all the same lengths, okay? They're not exactly, but it's pretty close, pretty close. So now what I'm going to do is connect it from there to there. So how many radians do I have now? I got 3, so that's another radian. Okay, so I got 1, I got 2, I got 3. But it's just a little short of 180 degrees. Something should be popping in your head right now. What if I went from here to here? Oops, I didn't do that very accurately. There we go. What do you think that little tiny bit right there is going to be? That little angle right there. Here's 1, here's 2, here's 3, and a little tiny bit. What's 3 and a little tiny bit? It's pi. 3 point what? 14. So guess how much this is? This little angle right there is how much of a radian? 0.14 of a radian. Everybody see that? So if I started, let's go orange this time. If I started, this is going to be really ugly because I can't keep my hands straight enough to do all this, but if I went from here ooh, that's not too bad. Look at that. It's not perfect, but it's not bad. All right, if I went from here to here, that orange one, how many radians is that orange one? It's 3.14, but it's better saying what? Pi. It's pi, and that's what we use a lot for this. It's pi radians. I did. All right, so this is pi radians. Does that make sense? All right. Where else are we right here? In degrees. This would be 180. So pi radians is the same as what? 180 degrees. All right, that's very important to understand that because we're going to use that concept here in a little bit. All right, so pi radians is 180 degrees. So let's do some more. I should have, let me extend this out a little bit. Extend this one out a little bit. All right, that's good enough. So if this is 180 degrees, how many degrees is up here? 90 degrees. So how many radians are, yeah, we can say that. How many radians is it from here to the 90 degrees? Well, it looks like it's half a pi. Very good. All right? Because look, from here to here is 1 pi, right? So this would be halfway, wouldn't it? Because 90 is half of 180. So what's half of pi? Pi over 2 is how we're going to write it.
So in our notes, what is pi over 2 is equal to 90?
Well, pi over 2 radians is equal to 90 degrees. Yeah? So it's at the same spot. So if I said, where is this spot right here? You would say, oh, that's 90 degrees. Again, starting from our initial side. Do you remember that? The way that we usually do it is from the positive x-axis. We always start here, then we go this way. So this would be 90 degrees, but it would also be pi over 2 radians. Got it? And then if I go all the way to here, it'd be 180 degrees, which is also pi radians. All right, let's go to another spot. Let's go to right here. So what is that in degrees? We did that yesterday. 270. Now, what would that be in degrees? Or, sorry, in radians? This would be 1 full pi, and then you go another half pi. So it's 1.5. Let's write it as an improper fraction, though. So what's 1.5? 3 over 2. So this would be 3 pi over 2 radians. You got that? So it's basically 1.5 radians. Or 1.5 pi radians, sorry. 1.5 pi radians. Not just 1.5 radians, because 1.5 radians would put you about right in here somewhere, wouldn't it? Okay, because that's 1 radian. This is 2, so 1.5 radians would be here. But it's 1.5 what? Pi, or 3 pi over 2. You could say 3/2 pi, but we normally say it. Everywhere you see it, it's always going to be 3 pi over 2. This is always going to be pi. That's going to be pi over 2. This would be 0 degrees, 0 radians. But what happens when you go all the way around 1 full circle? That would be 360 degrees. What would it be in radians, in pi, in terms of pi? It'd be 2 pi radians, wouldn't it? Okay? So it seems like all the way around the circle would be 1 pi, right? You're thinking that, but it's really not. Okay, 1 pi would be half the circle, and then 2 pi would be what? The whole entire circle. I just explained to you why. It doesn't matter how they came up with it. Just understand that it's true. Because if the length of this radius, right, was stretched around the circle, how many of these lengths, right, the radius length, how many of those could you fit around the whole circle? 2 pi. Or 2 times 3.14, which would be what? 6.28. So there's approximately a little bit more than 6 of these radii that can stretch around the circle. Okay? Not exactly 6, 6 and a little bit more. All right? Go ahead.
Is that true for like every single circle?
Yeah, doesn't matter how big, how small. If it's a circle, this is true about every single circle. Yeah? Remember we had those colors on there? Let's get rid of the orange. I could keep doing this, couldn't I? I could go 1, I could go 2, 3, and then I go 4, I go 5. Whoops, 5 would be about right in here. I go 6 would be about right there, and then a little bit left over. So how many radii, how many lengths of a radius can you fit around a circle? Of any circle. Doesn't matter if it's a small one or a big one or a medium one. Doesn't matter. You could get 6.28 circles, or radii, around that circle. Because it doesn't matter if it's small or big, because if it's a small circle, the radii is small. If it's a big circle, the radius is big. All right? But it doesn't matter. You're always going to get 6.28, or what? 2 pi. We're not going to say 6.28. All right? We're going to say what? 2 pi radians around that whole circle.
So what does this help us find?
There's a video that tells you. I don't think the one that I picked. Maybe I'll show it to you. Let's keep going though. All right. Here's another way, a little bit more mathematically. This is more visual, okay, but a little bit more mathematically. Let's go back to this right here. All right. So this S was the arc length, wasn't it? So that blue one is an arc length. That green one, that yellow one is an arc length. What's the arc length of the whole entire circle? Well, it's the circumference of the circle, isn't it? It's the whole way around the circle. So what is the circumference of a circle? 2 pi r. Agreed? Now, that's the length around the whole circle. What's that? Okay. So over the radius, so what's the radius? It's just r. Look what happens. This radius and this radius cancels. So what is the angle? This is a whole circle. This is an entire circle, okay? I'm talking about right here. So the whole circle is equal to what? 2 pi. So there you go. So there's how that formula works. And it kind of makes sense now, doesn't it? Once we saw the picture, right? So again, this angle is talking about the whole circle because this 2 pi r was the circumference of the entire circle, okay? So that's kind of interesting to see too, isn't it? All right, and so if the whole circle was 2 pi, what's half a circle? Well, it would be 2 pi, what? Over 2, wouldn't it? All right, and so what's a half a circle? It's pi, just like we said it was. They're right here, okay? So that's half a circle. What's a quarter of a circle? Pi over 2. I could do this. I could keep doing this, right? I could write, what? 2 pi, what's a quarter? Divided by 4, right? So that's 1, that's 2. So what is it? It's pi over 2. So that's pi over 2. I could keep doing that if I wanted to for all that stuff. We got it? You got a basic idea of it, of what a radian actually is? Yeah, I think that's the important part, is just to understand what a radius is. I'm sorry, not a radius, but what a radian represents, okay? Again, it's not really a unit like feet and inches. I can't say, oh, this is 1 radius or 1 radian, because a radian is different with every circle, right? Or the length of the arc is different on every single circle, depending on how big the circle is. All right, let's do an example. You ready? We're going to take some of the stuff that we learned, and what we're going to do here is pretty important. What we're going to do is convert from radians into degrees. And then we'll do that a couple times, and then we're going to convert from degrees into radians. All right, so first of all, what do we know about this? We know that 2 pi is 360, right? But what's 1 pi? What's 1 pi radian? It's equal to 180 degrees, okay? Now remember, we think of pi as just being 3.14, but this is pi what? Pi radians. It's 3.14 radii around the circle, all right? That's what this represents right here, okay?
Is that normal one just a number, or is it degrees? Or normal?
It's just in radians.
I'm
So
talking about if we weren't
No, you're thinking it. Yeah, I think I know what you're talking about. I don't have a great explanation for that.
Just units?
Yeah, I don't know how I can explain that. No. It's a good question. I'm glad you asked the question, but I just don't know how to explain that. But you do know that this is true right here, right? So 1 pi radian is equal to 180 degrees. So that's what we're going to do to this. So we're going to convert all these. We're going to convert from radians. They don't put this arrow, but I do, to degrees. Okay? So part A says take pi over 2. Now you already know what this is. We already talked about it, but let's show you how we can convert it. It is. So let's actually do it. So here's how I do my conversion. I call them unit multipliers. When I taught at my other school, I used this book, Saxon. I don't know if you've ever heard of Saxon math. They really taught unit multipliers a lot. I think it was super important. I think it's what some of these other traditional books don't do well enough. But this is what we did. If you got pi on the top, I want to convert from radians to degrees. So I want to get rid of the pi, right? A pi in radians, or a pi indicates that you're using radians, all right, whenever you see the pi. So I want to take that and convert it to degrees. So I want to get rid of the pi. So look right here. Pi and 180 are the same thing. If I put something over something else, if I put something over itself, what's that equal to? It's 1, right? And I can multiply anything by 1. I think we might have done that at some point this year. I can't remember. It was your class or the other class. But anyway, so I'm going to put a pi down here. Well, what's pi equal to? 180. So really, 180 degrees and pi radians are the same thing, aren't they? So really, this is just a what? It's a 1. So I'm allowed to multiply anything by 1. Yes? But what does that do for us? That cancels out the pi's. I got 180 divided by 2, which is what? 90 degrees, just like we thought it should be.
We did this in science.
Yep, it's definitely something in science classes. You would do a lot of conversion stuff. Yep, good. Let's do another one, part B. This one's a little bit harder. It's negative 5 pi over 6. Okay, we're going to convert that from radians to degrees again. So what do we start with? Well, we got to have a unit multiplier, don't we? So we got pi on the top. Where am I going to put pi to get rid of it? On the bottom. What's equal to pi? 180. All right, and now look what happens. The pi's cancel, and then you just simplify this fraction. We are not going to put it, if you can keep it, yeah, I mean, if you put it in a calculator, you're still going to get a nice whole number. But anyway, what can we do here? This 6 goes into 18, what? 3 times. That's a 30 times 5 is 150. It's negative. But what is it? 150 what? Degrees. So negative 150 degrees is negative 5 pi over 6. I'm going to show you something else, hopefully on a video. I actually have a little chart that I'm going to put up on the screen, but then I'll show you a video. I got to keep track on time, make sure I have enough time to show that video. All right. Everybody good with that? So we're converting from, radians to degrees. Now, these all had pi in it. Look at this one. Sometimes you don't always have pi in it, because what if I wanted to find out how many degrees like 1 radian is? Not 1 pi, okay, but just 1 radian, okay? What do you think that degree is? I mean, just take a wild guess. I was pretty close, pretty accurate, I think.
45?
It's a little bit more than 45. 45 would probably be about right in here, so it's a little more than 45, okay? All right, it's probably somewhere around there. Let's see what it actually is. Let's do the math and do it, okay? So this is part C. So 1 radian, it's not 1 pi radian, it's just 1 radian. There's a big difference between 1 pi radian and 1 radian, would you agree? Because 1 pi radian is 3.14 radians, all right? This is just 1 radian. So what am I going to do? I'm going to put 1, you put RAD just so you know it's a radian, put it over 1. Now, how do I get rid of radians? I got to put radians on the bottom. What do I consider a radian? Pi. And then I got to change it to degrees, so I put degrees up here. Now, nothing cancels, right? But what do? Just put that into a calculator. So that'd be 180 over 3.14, or I'll just put pi. I don't know if they use the 3.14 or actually the calculator button, but you get 57.3. So yeah, you're pretty close. You said 55. 45 is still not too far off. But do you agree that that's fairly representative of where 1 radian would be? Yep. So about 57.3 degrees. It's actually not a number that I had in my head. I would have had to do the math to figure that out. Okay, but that's 1 radian. All right, let's do one more like this. This.
1 radian just for this circle or for every?
So this would be, well, it would be for any circle, right? If I took a smaller circle and I took that radius and stretched it around, it's still going to give me 57.3 degrees. All right, it doesn't matter if it's small or big. Again, like we talked about before, the radius could be smaller on a smaller circle. Well, not could be, it is. It's smaller on a smaller circle, bigger on a bigger circle. It's still going to come out with 1 radian or 57.3 degrees. Okay? Let's do one more. So instead of 1 radian, let's go 3.5. So 3.5 should probably be where? Let's just think in our head. So 3.5 radians. There's 1, there's 2, 3.5. Let's see, or there's 3. 1, 2, 3.5 a radian would probably go to about right in here somewhere, wouldn't you think? Okay, so what angle do you, just top of your head, what do you think? 105? You sure?
Wait, that's yeah.
It's got to be beyond 180, right? If it's down here. Yeah, maybe around 200 something, 205 would probably be a good guess. Okay, something like that. But it's got to be more than 180. Would you agree? Because this is only 3.14. We want to go 3.5. So you're definitely going to go beyond that 180. So let's see what it actually is. All right, and we can figure it out. So what if we have 3.5 radians put over, then pi on the bottom, 180 on top, and you just put that in your calculator. 3.5 times 180 divided by pi, and you get 200.5 degrees. Okay? Everybody with me on that? Yeah. Now what do you think we're going to do? Going to go the other way. That's right. So let's go from degrees. I'll write that down. So this time we're going to convert from degrees to radians. I was watching a video, it was a while back, I wasn't even teaching this stuff, but he was doing some stuff in degrees, and he's like, oh, well, he said something like, well, we're all adults now, we need to do this in radians. So in his thinking is degrees, using degrees is kind of like a little bit of a lower level of working with this stuff. The higher up you go, according to him anyway, you're going to do stuff in radians. And we do. Like when we went to college, I never heard of a radian in my life until I went to college. All right, and here you are, what grade are you in? 10th grade now, right? 11th grade? You're 10th grade. And you're learning about this stuff. So that's good for you. I wish I had me as a math teacher. All right. So here we go, 45 degrees. All right, so let's write it. Let's write 45 degrees, put it over 1. We're going to multiply it by a unit multiplier. Remember, pi equals what? 180. So we're going to use that. That's what we're using as our unit multiplier. But this time, instead of putting pi on the bottom, what are we going to put on the bottom this time? 180, because I want to get rid of the degrees. I want the degrees to cancel out. So I put the pi on the top. Everybody with me on that? All right. And now you just work this thing out. That goes into that once. It goes into this 4 times. So what is that? It's pi over 4. And that makes sense, doesn't it? We did that earlier. Pi over 4 was, actually we didn't talk about that, did we? I think we almost did. Because pi over 2 is at 90 degrees. Pi over 4 would be about right there, wouldn't it? Okay, because that's 45 degrees. Because it's half of half a pi. Yeah, it's half of half a pi. It's a quarter of a pi, right? So that'd be a quarter of a pi or pi over 4. And that is 40 degrees, okay? We're going to do a whole lot more. You know how we had 30, 60, 90, 45, 45, 90? We're going to learn what each of those, like 30, 60, 90, 45, and then we're going to come over here. 30 from 90 is like 120, right? and then 30 from here would be 150. We're going to learn what the radians are associated with those degrees. I got a chart for it, got a little video for it as well. All right, but I got to finish this up, and I think I'll stop after that just because, yeah, there's no way I have enough time to do everything else. I'll finish it up tomorrow since I said we weren't going to do that other lesson, so I'll finish it up tomorrow. So we're good. Let's do another example. Oops. Oh, come on. B. What about 300 degrees? All right, you got to find out what it is in radians at 300 degrees. So what do? We go 300 degrees over 1. Put the 180 on the bottom so the degrees cancel out. Put the pi here. That goes, you can do the math yourself. That goes 3. So what do we get? 5 pi over 3. So at 300 degrees is the same thing as 5 pi over 3. Let's do a weird one. 138 degrees. All right, this is not one that we have memorized. This is one that we probably should know where it's located on the unit circle when we talk about the unit circle. Because we haven't even talked about the unit circle yet. That'll be the next thing that we do, probably tomorrow. All right, so how do we do this? Same thing, 138 over 1 times, put the 180 on the bottom, put the 1 on top. This actually does go even. That goes 23 times, and that goes 30 times. I think it goes 30. I think 6 goes into both of those. I didn't put the pi, did I? Put the pi right there. All right, so what's that? It's 23 pi over 30. Now, it's not always going to come out to be a nice, pretty fraction, all right? It could be ugly decimals and stuff like that, but these actually come out to be fairly nice. Everybody good with that? Okay. Let me see what else I got here. I think. There's one more thing I think we need to do before we get to the unit circle. Again, like I said, I'll save the unit circle for tomorrow. Let's draw another circle. All right, everybody watching? Try to draw this. It's not that hard. All right, this next one, I'm going to try to draw 60 degrees. So that would be 90, right? So 60 would be about right in there somewhere. And then I'm going to draw this. I'm going to try to draw this at 45 from here. So there's 90, or there's 90, there's 180, 45, about right, maybe about right there somewhere. Close enough. Yeah, it's kind of a messed up peace sign. All right, the length of that radius is 8. This angle right here is negative 60. Why negative 60? Because I'm going the other way, clockwise, okay? And they give you this angle, but they give you this angle in terms in radians. So they say that this whole angle right here is 3 pi over 4, okay? Which is 3/4 of a pi, correct? And pi goes all the way to here, so 3/4 of a pi would be here. This would be half a pi. That's 3/4 of a pi. Make sense? So you should have an idea what the angle is, actually. So what we're going to do is we're going to find the length. I'm not just going to change that into degrees. Okay, I want to find the length of each arc. And we actually can figure that out. So do you remember our little formula we had over there? S over R. S represented what? The length of each arc. The length of the arc, correct? So let's write this with S by itself. How would I do that? S equals what? R theta. Good. Everybody see that? Yeah, simple. Just multiply both sides by R. Boom. So that's how we find the length of each arc. Do I know the radius of this circle? Yeah, it's 8. Okay, that's what the 8 represents, the radius of the circle. Theta is your angle, obviously. And so let's see, I put arc A and arc B. So what does that represent? Arc A, again, we're not just trying to find the measure of the arc, we're trying to find the measure of the length of the arc.
Isn't arc B going to be like negative 120?
Well,
What is the relationship where it's double what the angle is?
that's a 30, 60, 90 triangle. The hypotenuse is double the short side. Okay? So let's take a look. Let's use this little formula right here. This is what we're going to use. All right? Again, S represents the length of the arc. So if I want to find A, that's kind of the S, isn't it? Because A is the pink arc. I want to find out how long is it? Not just the angle, all right? Because the angle would be 3 pi over 4. You could change it to degrees if you wanted to. I want to find out how long the arc actually is. So this is how we do it. So A is equal to the radius times the angle, all right? And when we do this multiplication, we are always going to use radians. We're not using degrees anymore, okay? Well, sometimes we will, but here we're using radians. So it's already in radians, so that makes it nice. So that's just 3 pi over 4. Okay, we can do the math here. 4 goes into 8. That's twice. So what is it? 6 pi. Now, if you wanted to find out like what it is in inches, like this is in centimeters. Okay, what is this in centimeters? What do we do with that 6 pi? Put it into a calculator. So you just go 6 times 3.14, and that gives you 18.84. And that's in centimeters. So what did we just find? What is that 18.84? It's the length of that pink arc. If I took a string and I took it here and I wrapped it from here to here, and I stretched it out and measured it, then it would be 18.84. You understand what we're finding? What don't you understand about it? Are you just saying that? Oh, okay. All right, let's do B. Let's solve for the length of B. Problem is, with this one, it's not in what? It's not in radians. So what's the first thing we're going to do? We're going to change it, right? So let's take negative 60 degrees and put it into radians. So how do I know which one goes on the bottom? Because the degrees on top, degrees on the bottom, so it's 180 on the bottom, pi on the top. The zeros cancel. 6 goes into that 3 times, so what do we get? Negative pi over 3, correct? Now we got to find the length of the arc. Put B equals, how do we find that? We take the radius times the angle. So the radius is 8 times the angle, which is negative pi over 3, agreed? And we just put it all together and we get negative 8 pi over 3. But that doesn't really make much sense to us. We want to find out how many centimeters it is. So we put that into a calculator, put in a 3.4, and you get 8.37. Now, does the negative bother us at all? I mean, is it going to even be included? No, because I'm just finding the length of the arc. So even though we have a negative right here, I don't really care, all right, what direction the length is going. I just want to find out how long the thing is, all right? Take a string, wrap it around the yellow, stretch it out, measure it, and it's about 8.37 centimeters. That's how you do that. All right, I barely have time to show this video. I got to change something on my YouTube thing. Let's go to computer screen. So now this is going to show the whole entire screen, I think. There we go. Woo, that's crazy looking. All right, and should have it ready to go. That's it. It's 5 minutes. Let me find I don't know how well the sound's going to come across on this. There is a way on this program where I can audio from computer. There we go. Oh, so I think I got to turn that off. Oh, I don't think it's working. Anyway, that's okay. It doesn't matter. Nobody's watching this on YouTube anyway, so who cares?
Absolutely do.
Well, this part right here. Okay, here we go. You ready?
Can be pretty easy. It's a little bit like cutting a pizza. So watch me slice this up. Hey, welcome back. This is Tammy and I do math for coffee. Okay, we have to start by talking about the circumference of the circle first. So starting with the whole circle, the formula for circumference is 2 times pi times the radius. Well, in the unit circle, the radius is 1, so the circumference is going to be 2 pi. Going all the way around this circle one time, that equals 2 pi. And that's radians. That's the basis of radians. The basis of degrees was 360 degrees as a full circle, but in radians, we know a full circle is 2 pi. So let's do a little more with that. The unit circle, we know it has a radius of 1. There are an infinite number of points on the circle, but the unit circle has 16 points that are super interesting. And the very first one is at 0. But 0 is also 2 pi once you go all the way around once. Now I'd like you to split that circle in half. And if you split 2 pi in half, you get pi. Now I'd like you to split the top in half, and if you take pi and divide it in half, you get pi over 2, 1/2 pi. Count to yourself 1 pi over 2, 2 pi over 2, 3 pi over 2. That is the fourth point. All right, let's find the rest of the points. We're going to start with this 30-degree angle, and I want you to think about this. You know that this is 180 degrees, and so this whole top part has how many 30-degree angles in it? It has 6 of them. So that means pi is split into 6 parts. Well, that means each one of these little sectors is pi over 6. So let's look at the angles. The very first one is 1 pi over 6. The second one is 2 pi over 6, but that's not in lowest terms, and so we're going to put that in lowest terms, and this one is going to be pi over 3. The third point, we already know what that point is. 1, 2, 3 pi over 6s. If you reduce that, it's pi over 2. That should look familiar. The next one, this is 4 pi over 6. 1, 2, 3, 4. We have 4 sections, so it's 4 pi over 6, also not in lowest terms. So we're going to write it down as 2 pi over 3. The next one, 5 pi over 6. That is in lowest terms, so we'll just leave it there. The next one is 6 pi over 6. This reduces to pi. Then the next one must be 7 pi over 6. This guy down here is 8 pi over 6, also not in lowest terms. So when we do that, it becomes 4 pi over 3, but it started out as 8 pi over 6. I hope you are seeing the easy way to remember this. You just set it up in the 6's and you count. So the next one would be 9 pi over 6, and that reduces to 3 pi over 2. We already met that point before, so okay, but now it still works. Like you can just count up by the 6's and you're going to end up with 3 pi over 2. So the next one should be 10 pi over 6, which reduces to 5 pi over 3. There it is. If you're following the pattern, you know what the next guy is going to be. 11 pi over 6, already in lowest terms. We don't have to do anything more with that. And if we close this circle, we end up at 12 pi over 6, which reduces to 2 pi, which is what we expected, right? This last set of points is going to be based on what happens when you divide this circle up into 45-degree angles. And 180 is the same thing as pi radians. Each sector is going to be pi over 4 in size. So the first radian will be pi over 4. The second one is going to be 2 pi over 4, which needs to be reduced to pi over 2. Again, we know that one already. 3 pi over 4, again, we're counting up. 1 pi over 4, 2 pi over 4, 3 pi over 4. This one's fine, it doesn't need to be reduced. Then 4 pi over 4, and that's going to reduce to pi. Moving down south, we have 5 pi over 4. This one is going to be 6 pi over 4, which reduces to 3 pi over 2. Again, there's repetition here, but depending on how you count up, you're going to land on that point again. That has to be 7 pi over 4. That doesn't reduce. Closing the circle, we end up with 8 pi over 4, which reduces to 2 pi, which is no big surprise, right? All right, let's put it all together. Now for the next thing we need to learn is how to find the coordinates for each one of those points. Watch that video next.
All right, so there you go. So let me show you. I'm going to get this printed off. I didn't print it off for today. Where did I put it? Should I put it on downloads? Yep. So here's one. The thing she said, what's going to be on the next video. Do you recognize these numbers? Square root of 3 over 2, 1/2. So now watch. It's kind of cool. 30 degrees and pi over 6 are the same thing. So what is the cosine of 30 degrees? Or what is the cosine of pi over 6? Remember the order? Cosine goes first, right? And then sine goes second. So the cosine is the square root of 3 over 2. And the sine is what? 1/2. What's the cosine of 45 degrees? Square root of 2 over 2. And the sine is also same thing. Okay, same thing with pi over 4. You follow me on that? So I'll have this printed out for you and give it to you. It's just, hey, you know, it's like a little convenient thing that you got. And right here, what is, if I ask you what the cosine of pi over 3 is, you're going to have to think where pi over 3 is, 60 degrees. And look, it goes over short and it goes up long. So the cosine is the short one, 1/2, and the sine is square root of 3 over 2.
You have to work. That's fine.
Do whatever.
Yeah. No, it's already a sign.
Yeah, it's 1 to 33 odds. Just do as many. Just do everything until you get to the unit circle. All right. So 1 to 33 odds. Do everything until you get to the unit circle, and then we're going to teach you unit circle tomorrow, and then tomorrow will be the last lesson I teach. Okay.